Hi, I'm going to walk you through how to extract data from systematic reviews and meta-analyses. Now, this is similar and a bit different than if you were, say, extracting information from a controlled trial or from say, an epidemiological study. Now, the types of studies that I'm looking at here are systematic reviews and meta-analyses of epidemiological studies. We're particularly interested in the associations between different types of respiratory hazards, airborne hazards like dust, etc., and different types of respiratory diseases. So I'm going to contrast two different articles. One is going to be the BLAN. This is put out by the American Thoracic Society. And the second is the Pochet, and it's, again, you can see it's a similar sort of looking at occupational environmental determinants in the roles of different diseases. Now, the first thing that I want to draw your attention to is the notion of a meta-analysis. Both of these are meta-analyses. And what those are is when they authors take data from the primary studies and, doing a little fancy math, actually combine those into pooled effect sizes. And let me show you what those look like. You will typically see these presented in forest plots. And you can tell very quickly if you're dealing with a meta-analysis as opposed to a narrative systematic review, because a meta-analysis will contain forest plots, or almost always contain forest plots. And so I'll scroll down here just to show you. Here we go. So you'll see plots that look like this. Now, what we're really interested in here are not all of these values, but really the ones at the end, the ones see right next to the, in this case, a red diamond. That is, if we take all of these, the data from these three studies, we combine it together, we get a pooled effect size and a confidence interval. Now, that is the data that we want to capture. And you can see in the Pochet, what they have done is organize their outcomes according to the type of exposure. So general dust, inorganic dust, organic dust, soft woods, wood dust, etc. But now let's look over at the BLAN. Again, we're going to scroll down until we see a meta-analysis. And again, this one looks a little different, but you see, again, we have the estimates from the different individual articles, and then the diamond gives us our overall estimate. Now, if you were paying close attention earlier, if your eyes are good enough, you may have noticed that the numbers were really quite different. So over in Pochet, what we have are odds ratios, all right? In BLAN, they're population attributable fractions. Now, we can calculate a population attributable fraction from an odds ratio, but in any case, we want to capture them both. So, how do we do that? Well, we have created an extraction template, and let me first walk through what that extraction template looks like. Now, if you're familiar with SRDR or Covidence or, any other type of data extraction platform, you'll know that you create a template, and then what you're going to do is from the articles, you're going to pull out specific pieces of information and then either pull that data into the extraction template or just answer questions. So here we see this would be something you would do in any other systematic review. What was the study design? And again, systematic review and meta-analysis, or just a systematic review with no meta-analysis. If inclusion, exclusion criteria. Now, one thing I've got to tell you about systematic reviews, as thanks largely to the influence of Cochrane, systematic reviews have a really pretty standard structure. And so if you know where to look to find a piece of information, chances are in the next 10, 12 systematic reviews you read, you'll be able to find the information, the same information, right about the same place. Inclusion and exclusion criteria you will find in the methods section. Study funding will often be reported at the end. The databases search, again, this is critically important, and you will find that in the methods section. They'll list out every single database that they searched. And then you can say here they searched the PubMed and Web of Science. Now, according to the PRISMA statement, which is a standard, kind of a writing standard for systematic reviews, what you really should have is a PICO statement: population, intervention, comparator, and outcome, and then you may have time frame setting, things like that. However, we don't always have that. And let me contrast the two articles that I've shown you. So first, it's the Blanc. You almost always will find their PICO statement or their purpose as the last paragraph of the introduction. So we look here, and then in the Blanc, they tell us, in this statement, we assess the occupational burden of 4 categories of respiratory conditions. So they're organizing this based on disease: asthma, COPD, chronic bronchitis, interstitial lung diseases, granulomatous processes, and then others, respiratory infections. Let's look at the Pochet. So we're going to run back up to the introduction section, go down to the end. Now, the Pochet is a little bit more sophisticated. They don't give us, neither one of these give us a PICO statement. But what they do is they give us our objectives. Conduct updated, do the meta-analysis, highlight the effects of the mode of diagnosis, etc. So again, we can capture this in our extraction template, and right there. So now let's look at ARMS. In our case, because we are looking at epidemiological data, what they're looking at is the difference in these diseases, whether you were exposed, the cases, or unexposed. These would be controls. So in both cases, I've defined the ARMS as cases and controls. The cases are the people with idiopathic pulmonary fibrosis in this case. Let's go on to ARM details. Now, ARM details, what we're really looking for here, and if you are not working on any of the projects that I'm working on, you would have defined your own ARM details. What is it that is important to know about, in this case, because of the ARMS, what diseases were examined? So we see in cases, in the controls, what types of exposures. Now this is important because right here we're looking at occupational, environmental, and agricultural, whereas the controls, they weren't exposed to any of those. How was the exposure measured? Now, this is important. There is a big difference between self-report and then objective, where it's measured by instruments. You could have air pollution measured by satellites, OSHA reports, all kinds of different things. Self-report is what was going on in the Blanc. So then we move on, and again, where are you going to find that? You're going to find that typically in the methods section, where they'll talk about, or in the intro, here's the type of exposures we're interested in, and then how they're measured. You might be able to find that in the methods. More often, what you'll find is these will be explained in some of the overview tables. Okay, so when they're giving the tables, how do they define the exposure? And you can see, so in this case, it would have been people who got work-related compensation, etc. It might be different for different outcomes. And so you have here, how was COPD defined? Okay, again, you may have to look into the tables to actually find how these different exposures or outcomes were measured. And we'll get to outcomes in just a second. Sample characteristics. Now, if you're used to extracting for, say, standard systematic reviews where you're pulling from RCTs, clinical trials, epidemiological data, you'll know that we are talking about the people that were in the sample. In this case, we're not. What we're really talking about is characteristics of the study. So what they did in this study was, how did they explain heterogeneity? Now, this is an important concept because, we have that one pooled effect size, but what we find is that very often there are meta-analyses, subgroup analyses that will sort of split out certain types of studies from others. Say, studies that adjust for smoking versus studies that didn't. Studies that adjust for medical history versus those that don't. And so what we see here is, and I'll just make this a little bit bigger, is what they did, and they didn't break it out by arm, but they did look at risk of bias. So our high-risk studies, do they have different outcomes than low-risk studies? Smoking, okay, studies that adjusted for smoking versus those that didn't. And then other, and then I just put this information in here so you can see what kind of data we pulled from there. Then we look at outcomes. Now, here's something I want to contrast these two articles. So in the Pache, remember, they organized by the type of exposure. However, in the Blanc, they organized by disease state. So let's look at how we set those up. So first, organizing by exposure. So we have outcomes organized by general dust. And let me just jump back to the Pache and just show you what that looks like. Remember, it was down here. Down here. Okay, so we have general dust, inorganic dust, organic dust. How does that look in our extraction? It looks like this. We also have the populations, okay? Remember, one of the things that that Pache did was they broke out by they presented the results in different ways. So you have the total, that big picture I showed you, but then within the narrative, they also give adjusted odds ratios for risk of bias for moderate studies, or where the ROB was high, whether there was or there wasn't tobacco adjustment. So again, taking those same analyses, but breaking them out according to the shared characteristics of the different studies. I use the populations tool to go ahead and be able to capture all of those differences. Let's take a look at the Blanc. So jump back here, go to the Blanc, and what we're going to see here under outcomes, the rest of it is all going to be the same, of course, but we see that he organized, or the Blanc and colleagues, organized by disease state. So they talked about asthma first, then COPD, etc. But what they did is they broke down in different cases, some of them, like for COPD, all the studies, and then only the studies that included non-smokers. When they were looking at idiopathic pulmonary fibrosis, they looked at different exposures, okay? And so again, we look at all of those. So the way that you set up outcomes, you really kind of have to follow the author and the way that they organize their story. Now, when we get to outcome details, what we're really interested in here is how did they measure their outcome? Well, in this case, because they were dealing with different diseases, it varied by disease. Some diseases they were able to actually use objective measures, say death certificates that had ICD codes, say hospital records, etc. Other cases, the outcome was self-report, maybe a survey. Did a doctor ever tell you that you were diagnosed with idiopathic pulmonary fibrosis, something of that sort? Authors will do it different ways, and so what Blanc did was basically take all those and put them together. Additional details regarding the outcome measure. Again, instead of reporting the odds ratio, which would be typical, they reported the population attributable fraction, and I just captured that formula right there. You can see it's derived from the odds ratio. And then were outcomes adjusted for smoking? Again, I said here mixed, because some studies, for some outcomes, they were able to adjust for smoking. That is to say, look at only the studies that included, that adjusted for smoking, and ignore the ones that didn't. Now, Now, there's this one piece down here for narrative syntheses. That's going to be more relevant for systematic reviews that have a narrative analysis. What we would do there, because typically those will go through and just have kind of long narrative of this study found this study found this. Really what we want to do for narrative syntheses for narrative syntheses is go to the discussion section or the conclusions and what are the main top takeaway points. We'll want to capture those. But in this case, what we're really wanting is those population attributable fractions from BLAN and the odds ratios from the Pache. So let me show you what that looks like. So I click on results, and what you see here is for asthma. Now, I have defined my comparisons using edit measures. I have the population attributable fraction, the lower confidence level, the upper confidence level, the min, and the max. Now, these are what the authors reported. However, there's a couple of other measures that are really important here and that we don't usually capture when we wouldn't ever capture when we are extracting data from primary studies. One is the number of studies, and the other is the I-squared. Now, the I-squared is a measure of heterogeneity, and let me show you where you typically find that. You see it down here, and actually just let me see if I can zoom in a little bit, move that out of the way, and zoom in. Do you see this right here? You have measures of heterogeneity. You have the tau squared, the I squared, and the H squared. What we're really interested in is the I squared, okay? And this tells us how much between study variance there is. Kind of think about how different the different studies are in terms of sample, in terms of design, in terms of execution, etc. And ideally, we want very low. This one has 0%. It doesn't really have 0%. It's never 0. It just means, in this case, very wide confidence intervals on that, and so it comes out as 0. More typically, you'll see something like what you see with organic dust, 42.5% as my I squared. Now, we want to capture that, and we also want to capture the number of studies. So we can see for general dust, there were 3 studies that contributed to this overall pooled effect size odds ratio of 1.32. So I'm going to jump back here. And I'll just show you, I created in my edit measures, okay, you remember I can create new measures as I need them. I created a field for the N and the I squared. So I was able to capture all of that. Let's see what that looks like in the Pache. So I jump back here, go down to results. And again, remember, Pache organized based on exposure, not on the disease. But we have very similar statistics here. So what was the I squared? 0. How many studies? 3. And then the odds ratio. And you can see these numbers here are going to map just precisely to what we have right here. Okay, so you see how that works. We captured that information. Now, again, a lot of this is very, very similar to extracting data and information from, standard primary studies. There are just a few kind of key differences. One are going to be the outcome measures are going to be slightly different. And the other is that, the way that systematic reviews, or the places that systematic reviews report this information, are typically going to be a little bit different, but once you get used to it, you know precisely where to look. The one last piece, risk of bias. There are 2 common risk of bias tools, Amstar2 and Robus. The research that I have seen that compares the 2 indicate that they operate basically equivalently. Robust might be a little better for meta-analyses, but on par, they're both equally easy to use. And you can see how I've set this up. So, did the research question inclusion criteria for the view include components of the PICO? Again, I was able to go in, even though we know they didn't make an explicit PICO statement. They did tell us who the population is, what the intervention, or in this case exposure was, what the comparator was, non-exposed, and then what the outcomes were. So I was able to get that and then make a decision. So the way AmStar is set up, you answer the questions here, make a decision, and then if you need a comment. Similar sort of thing for an explicit statement, the review methods were established prior. Now, what they, for partial yes and for yes. Again, in order to get a yes under the AmStar criteria, you have to answer, all of these would have to be selected. Well, in this case, a protocol should be registered, and it was, but they should also have specified, a plan for investigating causes of heterogeneity. But they didn't really give us a meta-analysis synthesis plan or really justify any deviations. So again, there were some things that they were missing. And so you would walk down all the way through this. Now, one thing that is a little bit different, AmStar actually is going to ask you to rate the overall confidence. So based on all the other questions that you answered, is it, do we have high confidence, moderate, low, or critically low? So here did any of the following questions receive a no answer? A protocol registered before the commencement of the review. Now, I think I misspoke above. I said they registered a protocol. They hadn't registered a protocol, but they did have those other plans. So because they missed that, according to the AmStar criteria, that is a critical flaw. And so it would automatically be low confidence. Now, I'll let you decide for your project whether, and especially depending on how far back you are going in time. It was only within the past several years that registering a protocol for a systematic review was really, really required. Before that time, some had them, some didn't. But that's really changed over time. But if you're including earlier studies, if they indicate that, say, they had an IRB protocol in place, that it was clear that they had a plan in place for how to go, you might want to fudge that one rather than automatically just kind of blindly follow AmStar criteria. But again, I'll leave that to you and your project. But there we go. So what we've done is we've kind of walked through two different types, or two similar articles, but that set up their results in slightly different ways. Based on this, you should be able to sort of read the systematic review, go through and answer the questions, basically fill in the fields, and you should be good.